welcome back to NCRT class 10th chapter number 12 electricity. Children, we are already started with the chapter called electricity, and under it we discussed about what is mean by electric current and what is mean by electric circuit, and based upon these we have solved few numerical problems. So children, with this previous knowledge, in today's class we are going to discuss about what is mean by electric potential and potential difference. So children, when I say the term electric potential means the charged body is going to do some amount of work, and it is called what here electric potential. That is the work done in moving a charge from infinity to that point. For example, if a charged object is there here, body is there, means in order to move that from this point to what this point, from infinity to particular point A, isn't it? Or you can take here any point, and whatever the work is carried out in bringing a charged body or charged particle from infinity to that point is called electric potential. So children, when I say electric potential means there it might include what? Addition of electrons or removal of electrons, isn't it? So it involves this addition and removal of electrons, mainly tells us something called work is carried out there, isn't it? When I say addition of an electrons means work is going to carried out there, isn't it? Similarly, when I say removal of electrons, there also some amount of work is done. So that is called what here? Electric potential. Amount of work done in bringing a charge, unit charge from infinity to that point is called electric potential. Children, let us consider the analogy of flowing of water. Why I am discussing means here generally the charges do not move themselves, children, isn't it? Something called pressure should be there. For example, when I kept that is two water tanks which are having a water filled with that and connected horizontally to another tank, isn't it? So if both the tanks are kept at same heights by connecting a horizontal tube, we cannot find the flow of water from tank 1 to tank 2. You know children, what is the reason? Because there is no pressure difference. If pressure difference not there means how can the water will start flowing? Isn't it? So what happens in this case? The water not flows. Water do not flows, isn't it? Suppose if the same water tanks, if I kept at different heights, if one I placed at a higher level and connected to the second tank, so now we can make what? Pressure difference due to the change in the different heights. They have created some amount of pressure. So now by making so we can see the flow of water, isn't it children? Flow of water is possible in the second case, but it is not possible in the first case because no pressure difference. If pressure difference not there means ultimately what happens? Water do not flows. If pressure difference is there means we can see the flow of water from tank 1 to tank 2. See here, the same analogy is also applicable for the cell, children. In the cells we have already learned that something called charged particles will be there. You know what are charged particles? Electrons here, isn't it? These electrons by themselves do not flow in a electric circuit. Means for example in a cell or a battery, they themselves do not flow, children. So in order to make them flow, we have to create some potential difference. Means that is called what? It's a electric pressure, the pressure which is generated in the cell, and it is called what? Potential difference. Got it children? Potential difference means here it is a type of a pressure which is created in the cell or a battery. You know children, let us make a small activity. I will show. By doing so you will understand clearly. Children, let us understand how the potential difference is helpful in setting the electric charges, means electrons in moving, isn't it? See, initially the battery and the terminals are not connected, children. So, when I make connected the terminals to the motor, the fan starts rotating. Let us see, children. See here. See, children, as soon as the one side of the terminal is get connected to the motor, it started rotating. It means that the potential difference has generated over and the electrons started moving through the motor, means current has produced there, and that current makes what? The fan in rotation. Means because of that potential difference, the fan started rotating and the electric current has produced over here due to what? The potential difference. Got it, children, here? Yes, this clearly tells us that how the potential difference is helpful in making the electric charges in motion in the conductor of a circuit activity. We can clearly understand that that is a cell or a battery sets what? The charged particles in motion, means the potential difference can be generated by using a cell or battery here. Then what is mean by potential difference? Children, potential difference can be defined as the potential difference between the 2 points in a current carrying conductor such that the amount of work done to move a unit charge from one point to another. For example, if I say the charged particle is at here, in order to move from A to B, whatever the work is carried out here, that is called as the potential difference between the 2 points. Understanding, children? The amount of work done in bringing a unit charge from one point to another point, means from A to B, and that is called what? Potential difference. And in general, the potential difference can be achieved or produced by using a cell or battery. This is a very important, children, because in 1 mark you may get question, isn't it? How can we produce a potential difference? There you have to write a cell or a battery. Got it, children? Then how can we express this, isn't it? And mathematically we can write that is what? Potential difference is equals to what? Work done divided by what? Charge, isn't it? See here, the potential difference is nothing but the amount of work done in bringing a charged particle from one point to another point, isn't it? That is the meaning. And potential difference is usually represented with the letter capital V, children. And already we know work is represented with the letter W and charge is nothing but a Q. So we can write that V is equals to W divided by Q is the formula for potential difference. And here the SI unit of a potential difference is volt, children, and it is represented with the small letter V. Here Alessandro Volta, it is the name of the Italian scientist who discovered this, isn't it, children? The SI unit of a potential difference is what? Volt. Got it, children? Yes. Once again I'll repeat what is meant by potential difference and how can we produce. The amount of work done in order to bring a unit charge from one point to another is called what? The potential difference between those 2 points. And here it can be mathematically represented as V is equals to W divided by Q, and the SI unit of a potential difference is what? Volt. Got it, children? Defined as 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done in bringing a 1 coulomb of a charge, children. See here, V is nothing but a here volt, means potential difference. J is nothing but it's a unit of a work done, isn't it? And C, the unit of a what charge. So whatever the amount of work is done, that is what, especially 1 joule of work is done in bringing a 1 coulomb of a charge is called 1 volt. And the potential difference is in measured using a special device called that is voltmeter, children, isn't it? Potential difference can be measured by using an instrument called voltmeter, children. See, remember children, in an electric current, to measure the presence of a electric current we use ammeter, whereas to measure the potential difference we are using voltmeter. Got it, children? And remember, always voltmeter should be connected in parallel. Connected in parallel. For example, if the resistance is connected here, say this is having some ohms, 5 ohms. If you want to measure the potential difference across it, means how we have to make parallel, children, means down we have to connect, isn't it? This is what the meaning of a parallel connection we have to make, children. In order to measure the potential difference, the voltmeter should be in a parallel. Got it, children? Okay, now we will solve a few numerical problems based upon potential difference. Let us start with the first question. How much energy is given to each coulomb of charge passing through a 6-volt battery? Children, when your there is coming across with each coulomb, means here 1 coulomb you have to understand. So what are the given data, children? Here that is coulomb, means charge value they have given, and battery, nothing but here the potential difference value they have given, and we need to calculate energy, nothing but a work done. So what are the given data, children? That is each coulomb means what is that? Q is equals to 1C, isn't it? Then potential difference, V is equals to 6 volts. Then energy, isn't it? W is equals to how much? So use the formula V is equals to W divided by Q. Now substitute the given values, children, isn't it? That is V is nothing but a 6 volts is equals to W. We need to calculate, keep same as it is, and 1C. Q value is what? 1C, and cross multiply this, isn't it? W is equals to 6 volts into 1C, means W is equals to 6 joules. So we the energy used here is what? 6 joules of energy is used in bringing a charge when it has connected to 6 volts battery. Children, let us solve one more problem based upon potential difference. Here they asked how much work is done in moving a charge of 2 coulombs from a point at 118 volts to a point at 128 volts. See here they have not given in this question potential difference directly, children, isn't it? The point values they are given here. So you have to do what? The potential difference you have to calculate first. And one more thing they have already given, that is charge they have given. So what we have to calculate? How much amount of energy used here we need to calculate. Okay, that is the given things are the potential difference V is equals to, what are the points, children? 128 volts and another point is 118 volts. So 128 volt minus 118 volts. So you will get 10 volts is the potential difference. And the next value is what? Charge, isn't it? Charge Q is equals to 2C, means 2 coulombs, and work W is equals to how much? Then use the formula, children. Here V is equals to W divided by Q. Now substitute the values. V means 10 volts, W keep it as it is, Q means 2C. This implies that W is equals to 10 into 2, which is what? 20 joules. So what is the answer, children? 20 joules of energy is used in moving a charge of 2 coulombs from a point at 118 volts to a point at 128 volts. Got it, children? The simple, if the two potential difference values they have given means you have to calculate its overall value. That after, by using that you have to substitute in the given formula and you will get what? The work done value. So is it clear, children, the concepts and how to solve the problems, isn't it?